I'm going to titrate flask A first because flask A contains the least amount of acid and should then require the least amount of base to neutralize that acid and end up at a neutral pH. In order to track the changes of the pH of the solution, remember we've put 2 drops of phenolphthalein indicator into the flask. Since the flask currently contains an acidic solution, apparently phenolphthalein is clear under acid conditions. But what is the color of phenolphthalein under neutral and basic conditions? So you will see this as the trial unfolds. So I'm going to open up the valve of the burette on full and allow the base to stream into the acid. Now right where the base is mixing with the acid, you can see that pinkish color. Now, that pinkish color is the color you're shooting for. That is the color of neutral solution when using phenolphthalein indicator. A red color, a red wine color, is typical of a solution that has gone past neutral and is into the basic range. And again, you will see that before I'm done. So you'll notice that the color went away very quickly, and that's an indication that you're very far away from neutral. And you should use these indicators to adjust the rate at which you add base to your solution. If you're adding base to your solution quickly and there's little to no color, you can continue to add the base quickly because you're nowhere near neutral. You will see that as we get closer to the neutral point, the color will take longer and longer to decolorize, and it will also fill a larger volume of liquid in the flask. So I'm turning the stream of base on again. And now you can see the area that is colored pink was much, much larger in the flask. And that's telling me that I'm much, much closer to a neutral solution. So at this point, I want to slow down. I don't want to add base so quickly. Now I am doing 3 trials. If I wanted to, I could do the first trial, what I call fast and dirty. I could open up the valve, wait for it to turn red, and quickly close the valve. I'll pass the end point, but not by very much. And the time I save on doing that first trial fast and dirty can pay me back time dividends as I do the other trials. But I'm going to go slower at this point. I'm not going to turn the burette on full speed. I'm going to have more of a dribble. All right, so here's a drop every second or so. And you can see that colored area where the drop splashes in, but it doesn't really last long, and it does not fill the entire volume of the flask. So again, these are important indicators telling us that we're not really close to the end point. And you're going to notice that that colored region is slowly going to get larger and larger. And that, remember, is an indicator that we're getting closer to the neutral point, and we should probably slow down. In fact, I'm starting to see that already. All right, so I'm going to turn off the burette. And there, after a few seconds, the color disappeared. So now I know we're close. We have both indicators of being close to a neutral endpoint. The volume of colored liquid is going up, and the amount of time it takes to decolorize the solution is increasing as well. So now I'm literally going to go drop by drop. And this is the toughest part for students, to take the burette, which is fully off, and slowly turn it on to deliver one more drop. Now the key to that is to watch the tip of the burette. As you slowly turn the handle of the valve of the burette, you will start to see a drop forming on the tip of the burette. The speed at which the drop forms at the tip should inform your hand and tell you how much faster or slower to control the valve so as to get just one more drop. So watch for the next drop to fall in and watch what it does to the solution. All right, it's forming. Here it comes. All right, now, That one more drop, look at what it did. It took our solution from a clear solution to a very pale pink solution. And this is exactly what you want. Listen, folks, this is some dumb luck here, all right? This very, very light pink, so light that you and your partner might be arguing over whether or not you're looking at pink, is the color you're shooting for. This is a perfect endpoint. Now at this point, I would record the volume on the burette, and trial 1 is done. If you let this sit, it will decolorize over time, partly because of carbon dioxide in the air dissolving in the solution, reforming a weak acid and taking the solution away from neutral. But I'm going to go and add one more drop to show you what it looks like when you pass the endpoint. So I'm staring at the tip, I'm watching very closely for that drop to form. All right, it's forming. Here it comes. Boom. Now that is just one more drop, folks, and look how much deeper that color is. So this is the color of phenolphthalein when it's in the basic range. That light pink is an indication that you're in the neutral range. And this is one of the great things about titration. By its nature, it is a very precise technique. You can see that it's accurate to within a drop here. Now there's also a way to do or deliver a fraction of a drop. I won't be sharing that procedure with you, all right? Getting to the nearest drop is just fine for our level of chemistry. If you saw the graph that governs this process, you would understand why it's so very sensitive. But that's a little outside the scope of our particular course.